all this works together to provide a range of self-service capabilities that for how DevOps teams and developers prefer to interact with infrastructure, right, around Kubernetes. And Kubernetes itself and developer tool sets that are being optimized or that have already been optimized to work around Kubernetes environments use these type of constructs, right? These YAML Kubernetes manifests to be able to deploy resources. And so with the integration into vSphere, we can do things like deploy Tanzu Kubernetes clusters as in a Kubernetes manifest, as well as standard pods, and also virtual machines, providing really a new, a totally new way for developer self-service to be able to leverage the virtual machine environments in more highly automated and developer-friendly access methodologies. By bringing virtual machines into this Kubernetes construct, it provides an assurance that this is not only a methodology and a format that developer organizations are comfortable with. It is in the format that I think just the developer community at large has spoken that this is their preferred format. This is their preferred methodology for interacting with infrastructure. And as well as, again, additional custom resource types that we're able to deploy through the VMware Marketplace and leveraging the Kubernetes extensions. Okay, now as we get into Kubernetes networking, one of the core tenets of the vSphere Tanzu architecture is the batteries included but swappable approach, and so vSphere Tanzu includes complete enterprise-grade networking capabilities that also have multiple options, right? So options from using the standard vSphere distributed switch capabilities. We also support, we have support for open source solutions, as well as for NSX for customers who have NSX licensing. There's a whole level of additional and enhanced functionality capable through NSX integration. So for our networking and more specifically our container network interface for Kubernetes networking, there's a choice of Calico or Antrea container network interfaces, and Antrea is the Calico and Antrea are both open source, popular open source networking solutions with integrations and support for Kubernetes. Antrea is a new solution that is open source but backed by VMware, and it's really created by the same team that created Open vSwitch, which has really become a staple in the Linux community. And so Antrea is the default CNI plugin, and again also support for Calico as well. Now we'll take a deeper look at vSphere with Tanzu services. We'll look at how self-service management of Kubernetes clusters works for developers. And so in addition to having TKG APIs and a CLI interface, for vSphere with Tanzu also offers extensions for kubectl. For any developer or DevOps team that is working with Kubernetes, the kubectl syntax is really the most common tool, the standard CLI tool to interact with Kubernetes clusters. And so this puts us in a very familiar context. Use standard Kubernetes manifests and standard Kubernetes commands to be able to request services. And again, the administrator is able to define templates, so of sizes and policies that are available. So when a developer wants to request a cluster, there can be certain sizes, certain kinds available that are kind of pre-templated for the common types of Kubernetes cluster definitions that are needed in the organization. Okay, automatic load balancer provisioning. So one of the really powerful features of Kubernetes is that it has standard load balancing services integrated in the nature of how it works. And so whenever you prepare applications to work in containerized environments and go to deploy them in Kubernetes, it's the how do I automate load balancing it's such a standard and simplified, optimized way that works for all the applications that run in the Kubernetes environment. And so, but when you are the platform operator for Kubernetes, you install Kubernetes on the infrastructure, you have to provide a load balancing service that has the adapters and is configured and integrated to support. So when a developer says they need to create an ingress service, when they need to access a load balancer service, for example, that the Kubernetes installation itself has the ability to fulfill those requests and provide those automated load balancer services. And so the vSphere with Tanzu includes the network service and the supervisor cluster that will fulfill these ingress and the ingress and load balancer requests to be able to provide those full-featured services to the developers and consumers of the Kubernetes environments. Now we'll look at the integration of the VMware vSphere Cloud Native Storage and vSAN. And so vSphere has had support for attaching volumes and providing storage services for Kubernetes and containerized workloads for several iterations now. And the newest is cloud native storage. It's really native integration and native support for cloud native storage volumes. And so we get first class visibility and access to policies, access to tooling in vSphere. Anytime, in Kubernetes, when you request a volume to be attached, the volume that you attach to that container is the same exact volume from a vSphere perspective that you might attach to a virtual machine. So really enabling that vSphere admin to be able to, again, apply all their knowledge, all their skills very quickly and reliably support a robust storage service, and at the same time the developer having access to a rich array of capabilities that they can access through Kubernetes. And here we see an example, right? We can see here these on the left side of the upper diagram, like MySQL or Redis, are examples of applications that would request volume services from the underlying infrastructure provider. Cloud storage interface is the service, that definition that from the Kubernetes itself on how various underlying infrastructure providers can interact with to provide those storage services for Kubernetes. And under here we see the cloud native storage control plane is able to communicate directly with the cloud storage interface and provide a storage-based policy-based management for vSAN and vVolumes, VMFS and FS, and also file services to be available for requests through Kubernetes. Now, another, again, powerful construct here that really helps is on one side of this equation here, on the developer side, they're used to thinking in terms of Kubernetes, and they would prefer to interact with Kubernetes when they're examining their application deployment and maybe their DevOps practices. And at the same time, vSphere administrators who would support the underlying infrastructure need to be able to speak a common language. If a developer is looking at application performance and something with a volume, and they ask Kubernetes, they run a Kubernetes command, and Kubernetes gives them certain types of identifiers, and they contact the infrastructure team for support, they need to be able to communicate through the terms of Kubernetes and have the support person on the vSphere admin side be able to really understand and relate that to the underlying infrastructure objects and vSphere services that actually fulfill the requests for the volumes. And so you can see here, for example, that common language of how by looking at different views of the same objects here in the vSphere interface, we can find the Kubernetes identifiers in that language that the Kubernetes developers are more familiar with, and easily click in to see familiar vSphere administrator contents so they can use their expert skills in doing any troubleshooting needed to support delivering robust storage services.